Today we're going to give you a little bit of a background of UF Health, kind of our digital path, how we went. This is kind of a customer side to this. We realize we're speaking to a room of people whose profession is to do commissioning. We're in the process of living this out in the trenches on a day-to-day basis. Talk a little bit about our processes, what we've learned, what we still struggle with, and then talk about how we kind of manage this going forward on a holistic approach. Real quickly, UF Health, it's the Academic Medical Center for the University of Florida. We have two academic medical centers, one in Jacksonville, one in Gainesville. There's a number of other hospitals that we have with us. We have about 100 locations overall, including a lot of the clinics, primarily located in North Central Florida. One of our strategies has been how we work on keeping our market. About 30% of our market is local. Most of our market is actually referral. So some of that's been done with partnering, but a lot of that's been done with branding. So we've gone out and created affiliations with Sacred Heart in Pensacola, Halifax and Daytona Beach, Orlando Health in Orlando, so that some of our programs and physicians and services share across, and we get to share the UF Health brand without actually having to go and own a piece of the market. Since most of our business is tertiary, quaternary, it's really for us is more about a referral system than actually having to have people walk into our primary care clinics. So our mission for sustainability is really tied around our perfect patient experience. And that's what's going to drive everything we do. So when we talk about commissioning, it is about energy because we do want to be sustainable. But at the end of the day, it's about building a quality health environment for all of our patients and our staff to be able to work. So the sustainability initiatives are important, especially within our community. We'll talk about that when we get into some communication conversation. It's good for us to be seen as a good partner in our community, both regionally and locally, and an example of an organization that cares about our world as we move forward. So our digital path started really in the 90s. We had some performance contracting. We integrated some digital components into large pieces of equipment. And for any number of reasons, it didn't really take on. I mean, we had some electronic controls and things, but it didn't. We weren't able to use the tools, probably didn't think about what we could do with them as much. And it wasn't until the early 2000s that we really started rolling out digital control boxes. So renovating an old building, we were putting digital controls in all the VAV boxes, and anytime we go back and upgrade a piece of equipment, we were putting controls on that. And then in 2006, we had an opportunity to build a new surgery center, and it was our first fully digital building. Mark's going to talk about that and some of the gains we got out of it, what we learned, and how we're continuing to manage it a little bit later on. But that was our first foray into saying, okay, we need to fully embrace this all the way through. And then in 2009, we opened a 500,000 square feet cancer hospital right across the street from the main hospital. And that was a full digital building. And one of the things we'll talk about is it was probably more digital than we needed. We learned a lot about points that you don't need. And just because you can measure it doesn't mean you should. So we'll talk about that in a little bit also. And then we're in the process of adding a heart and vascular neuromedicine hospital, which comes over to us in September, another 500,000 square feet, and will open in December. And that is, again, another digital project. So now we're looking at back within the existing hospital, another 1.5 million square feet that has been there in a variety of years from the 60s all the way through the 80s, and having to go back through that and start bringing that up to a platform that we can use. So all in all, we've got about 30 facilities within a 10-mile radius of us that are reporting back and working. It comes into our Enterprise Building Operations Center. And so we have a central point manned 24/7, 365, where all of our points come back into. We have proprietary fire station. Everything comes back into that point. It's pretty robust. So we answer all types of alarms that may come over the system, whether they're temperature alarms and freezers or patient med refrigerators, but also our air handling systems and things like that. Some of the problems that we continue to work on, really that I mentioned it, too much data or unreliable data. It's funny when you tell nursing, I can help you out by monitoring this patient refrigerator, and you don't have to fill out the log 3 times a day. I can monitor every 5 minutes, and then I find out the guy from food services runs and throws a case of Gatorade in and spikes the temperature, and now my alarms are going off. Didn't pick up when nurses were taking care of it because they were only doing it a couple times a day. Now I'm monitored every 5 minutes. So we had to go and say, all right, just because we can measure it that often, maybe we shouldn't. Maybe we need to build some algorithms that allow this to pace out and we take an average over a period of time. The skill gap is something that we are still struggling through. Going from a wrench to a joystick is a tough shift for some people. Others get it. We've got people that are younger that come in that have the joystick abilities, but they don't necessarily have that intuitive wrench skill. And so how do you train those? Because you need both of those skills in order to manage what ultimately is a physical mechanical system, but understand the electronic side of it and data if you're going to be able to effectively use it. And then we're dealing with staff retirements. That's probably a little unique to UF Health. We have a lot of people that have been there 30 years, partly when the organization started. As they retire out, we're losing 5+ people a year in some areas, and that can be difficult to fix. Our future, as we look forward, we believe it's important for us to we'll call it right-size our digital footprint. So placing monitors and monitoring systems that have benefit to us that we can use to manage our buildings. If you're not going to do anything with it, maybe I don't need to measure it. And even if I am measuring it, I need to think about what's the right way to go about doing that. We call them canaries, but expanding if you have an existing pneumatically run building, and I need to have some ability to enter information into my digital system, how do I go out and pick up a few pieces at the end of the run and put some kind of, I call it a digital canary in the coal mine. Tell me what my system's doing. It may not run anything, but it gives me data back and allows me to go make adjustments, and it allows me to go and impact my work order system. Digital requirements for renovations. I think we're in pretty good shape there. We've committed to an all-digital environment. Every renovation we do goes after it. We've set up our standards so that if you have to do a replacement piece of equipment, you are going to buy a piece of automation or a digital package that goes with that. One of the things we've been working with our IT group is the whole idea of the digital security. I mean, everybody in this room probably is aware of whether it's the hackers or what we found also in a broader environment like a university is having things that might be named the same. So we went to an aggressive naming convention. We've taken advantage of the full 32 characters that are allowed. So they're long names, but I think Mark and Sam will tell you it makes it easy to sort, it makes it easy to see it, you know where the device is, you know what it is and what it does. And so it's worked well for us. But anytime you have something that is not unique anymore, it no longer is worthwhile for you in data. We've also learned that we want to manage every energy source. Doesn't matter what it is, we are going to sit down and try and find a way to go after it, because even the smaller ones, if there's a lot of them, can have a pretty significant impact. And then finally, we continue to work on ways to integrate our building automation and our work order system, our maintenance management system, so that some of this stuff becomes automated. I don't necessarily need to have a report come to somebody and then they go find somebody to get something done. These things, along with protocols and work steps for a mechanic that has to go out there and take care of it. And one of the things that's changed, Mark's going to talk a little bit about, I may not be taking care of the same type of equipment in the future because some of these sensors come with their own requirements. So Mark, I think you've got some success stories that you might want to talk about and let them know where we are.
As we said earlier, I am Mark Dykes. I've been fortunate enough to serve as the energy manager there at UF. I've been at UF now for 33 years. And recently, our team has been instrumental in creating several $1 million of savings recently. We got a couple ASHI Energy Carat Awards, kind of motivating. This year, our utility budget will actually top $15 million for 4 million or so square feet with another new hospital coming online that Brad mentioned, a CVS cardiovascular tower. And this is really not, though our story today is really not about how much money we saved. It's really about keeping those savings in our pocket. You ever had any problem with that? And we'll talk about the tools we have in the bag and how they help us accomplish this. And for the story today, we'll talk about a few of the buildings we've impacted recently. Right here, you see a 5-story office building. We went in there and commissioned it. We created $100,000 savings and a 17% reduction. What happens next? This is really our story. This is the cancer building that we opened up in 2009, Cancer Tower, 500,000 square feet. We went in and commissioned a brand new building, in-house, by the way. $600,000 savings for the first year, 15% reduction. Primarily got it from simultaneous heating and cooling. Same old story, right? Currently working on some other major energy conservation measures being implemented soon. Again, what happens next? This is the surgery center Brad spoke about, our first fully digital building. It sat there for a year. We said, let's see if we can go in there and tell this building what to do. We were able to do that, created a $50,000 savings, a 22% reduction the first year. Savings came primarily from building setbacks, optimizing airflows for the OR suite. I know you get tired of it, but what happens next? Let's see the next slide and I'll show you. So let's go back to the office building. It's a 180,000 square foot, 5-story office building. And really what we're about is this little triangle right here. Does this look familiar? That's really what we're talking about today. South Tower, maintaining the gains, same old story. That's the 2009 building, 500,000 square foot building. Do we commission and walk away and forget? No way. Here's our surgery center, still chasing the gains. We did really well the first year. We kind of watched it for a while, said, this is going to be fine. This is some of the typical issues that we see after commissioning these buildings. So what are some of the causes of this phenomenon? I mean, y'all have seen it. We used to call it that. Now we have a powerful tool that we can actually see the actual evidence to direct us to the root cause. It's a powerful tool. We'll talk about that briefly, shortly. So what are the problems this can cause? This happens to be in an exhaust flow air box for an isolation room. So we talked about our data. Brad elaborated on how robust our system was. So we're able to go back and draw a picture of what occurred actually with this flow ring. Now we have approximately 750 VAV boxes in this hospital, about 400 supply and return boxes. So just consider velocity pressure flow rings as we talk, and exhaust boxes and return boxes. This is 7 years of data, and I mean using this data is really paramount. So you can see as the top line there is our damper position on our box. So you can see in the first 12 months we went to 100%. Well, as that flow ring was beginning to get blocked, what happened to our air? The automation system's still reading the air, but you can see it drop from about, it's not 40, to make the graph work, I took an extra 0 away from the flow, from the actual flow. But you can see our set point was about 550, and you can see it diminish. And by the time it was cleaned, it was indicating 260 CFM. But because it's trying to open, the box goes to 100%. The box was actually doing 800 CFM. You can see where it was cleaned 11 months later. So what does that tell us like today? It's still stopped up. The room's a negative isolation room. We've got a plan to go over. We've got to, it was one of those lessons learned. to where we need to provide access to be able to clean these flow rings. We have the people, we just need to be able to provide access to do it.
And a preventive maintenance work order to make sure it happens on a timely basis.
So due to the fact that we have numerous isolation rooms in this building, like 22, if you take that delta of 800 CFM, that's about 8,000 more CFM negative that we are in the building. So in Florida, we know about the issues that can cause. Is it not enough air, too much air? More fan energy, more outside air, $5 to $6 a CFM a year, it gets quite expensive. The problem we had, because we didn't, again, lessons learned, we actually got a complaint that a couple of the floors were sweating. Brand new building, less than 2 years old, and our floors were sweating because we were pulling so much negative air. Building envelopes, obviously in Florida, it's key to maintain them. Cost associated, again, outside air, increased fan cost. But operational issues with pressure-sensitive rooms. We have a few of those in healthcare, correct? So what do we have in ORs? We have return boxes. Our ORs are supposed to remain positive. How are you making sure we do that? A great tool to allow us to be proactive and not reactive, and actually to be able to predict failure now. It's a pretty neat concept. Here's another tool we have. It's a reporting tool. It's a Microsoft reporting tool that goes into our SQL database. Again, our database is, we have about 9 years of trending data. We trend, again, all of our points, 200,000 plus points every 15 minutes, 24/7. So we're able to use this reporting program basically to build a parameter for basically chill water valves, heating hot water valves, dampers, anything we want to do. It's basically a custom program. But for this report, you can see how you can enter the numbers up there. So what I did, just for this presentation basically, is I went in at 2010 prior to commissioning this building, and I said, show me, can you see the numbers up top? I can tell them, but show me how many of those 740 reheat valves are more than 30% for more than 50% of the time. So that, and this was July in Florida. So 50% of the time would be, how many are greater than 30% for more than half the month? And also the search date, obviously, the building name, PO4, and a wildcard search, BZ.HVAL. That happens to be about a fourth of our naming convention, but it does work. It's key to being able to do this reporting. Again, for the month of July in Florida, in the third column, Brad and I had a bet. He said you couldn't see these numbers in the third column. In the back, what are these numbers? 100, yes. I get that dinner, Brad.
Yeah, I wish we'd bet dinner.
So, again, you see our reporting. This is page 2. This is page 3. 100 means they met the criteria of that search. Page 4. Page 5. Page 6. Oh, there we are. 255 reheats met that criteria in July and August. So just to show off the reporting a little bit, maybe pat us on the back with our progress, able to use this reporting tool to track our progress after commissioning. We have one culprit that I ran 4 or 5 days ago. Now the same search, it's 20%, it's actually 30% of the time. But 100, there's one culprit that stays at 100%, we know which one it is, so that will be fixed.
I told Mark I was really proud of him because even an architect can understand the color coding. It worked out great.
So we make reheat how? We make reheat by steam typically, right? So we get our steam to make reheat off a 4.3 megawatt turbine that's a byproduct that we get the heat for free. We used to only be able to make about 400 tons. The steam that we save, we're able to make almost 700 tons of free chill water now. So we get kind of a double benefit there. All right. I think I skipped one there. Okay, this is just other issues that can happen. I call this the lobby scenario. So in our brand new hospital, we have 4 boxes at 800 CFM apiece. So I've got 800 CFM, and I love to use July for reheat. This is July. I wanted to keep all the dates off there because it gets real muddy. This is July. I have a heating hot water valve at 0, and I've got my discharge on my box that never goes below basically 85 degrees. So I've got that box in a lobby with 3 other boxes. So what's happening to the other boxes? What's happening? What are the dynamics in there? It's not a trick question. So the other boxes really are fighting to keep that zone cooler. So in a max-min scenario, the boxes never can go down from 800 to 250 times 4. So that's 1,000 CFM. So not only more reheat with these boxes, but increased fan energy, right? Because we can't implement our maximum. Okay, there we get to the fun stuff. So I kept seeing this discharge air temp on the air handler go from 55 to 52, and I went and asked our staff person that did that, and he said, well, we can't stay cool in there. And the lobby's nice and positive. So we dug into it, and with the automation that we have, it's easy to exploit the power to fix a problem. So to change a temp from 55 to 52 is just a click of a button, and obviously it can mask the real issue and create major cost in other areas. So he's going to drop this temperature from 55 to 52 to fix the problem in the lobby. What about the 40 other boxes that aren't even in the lobby? We're going to reheat more and more and more. Okay, let's keep going. So did that fix his problem? Fixed his problem, work order closed. What else does it create? We already talked about that. More reheat from the other 40 boxes on the other air handler and additional fan energy. Another example here. Chill water valve off. This is an air handler discharge air temp. About a 40,000 CFM air handler, 55 degree set point, chill water valves off, and we're doing 48 down to 46 degree air. In July, again, so what are all our reheats doing? Excessive reheating. So you can see I took the 4 largest boxes on that air handler, comprised of about 3,000 CFM, and you can see the reheat. You can see where one of them was just 100% all the time. Substantial cost right there. So the rules are simple. Maintain your set points and you save dollars. And in our world, set points are much more than a discharge air temp or a heating set point. They can be cooling tower reset temps, duct static pressure resets, outside airflow stations, room flow deltas, temperature sensor calibration, economizer rules. There's a lot of times 5 months in North Florida we can economize. Differential pump resets. We have some pumps that are 250 horsepower. Building pressure monitors, air handler DAT temp resets, they're all really a set point. Coil DP alarms for cleaning, maximum inflows for VAV, OR room sensors for occupied, unoccupied, kW per ton production, and just tons more. And yes, we also have a heli mode. Anybody ever heard of a heli mode? You got any hospitals that deal with helicopter fumes? Manipulate the system to avoid those issues. We have that. So managing these costs and keeping these savings in our pocket can be overwhelming with what we do. We have a powerful EBMS comprised of over 200,000 points, 9 years of trending data, a fault detection program, utilizing that unique name, and most importantly, a highly skilled team. They all make this happen. This highly effective combination really is not only required but crucial to what we do at UF. Not only maximizing energy dollars, but also maintaining an optimal environment in an intricate world-class healthcare system. So are your customers, the people that you talk to, are they familiar with these stories? Do they know what it's going to take later? Are you preparing them? Do they understand the term holistic approach? Looking at all the pieces, not just step one. How are you equipping your client for the necessary tools and information to be successful in sustaining their gains once you leave their facility? Waning savings, bad. We sure didn't like to see them. Do you let them know technology, a group of people with a specific skill set, advanced training, the person with the joystick, continuous commissioning, and resources are all needed for success in our endeavor and their endeavor? Do you talk about reinvesting savings for continued improvements? Just remember, their success is y'all's success. So keep up the good work you're doing, and I really thank you for allowing me to share some of our experiences at UF. We're going to have some dialogue.
Yeah. While Sam's coming up, we took the last part of this and put it into some major kind of buckets of discussion so that we could start to have some dialogue. It's almost a question and answer between ourselves to try and get some information out to you, and then obviously a chance for you guys to do that as well. One of the points that Mark had on his slide was the culture change. And you saw the solution for the maintenance engineer that changed the set point in the lobby, and then it affected every other box in the building. That is how many things get done in a facilities manager's world. You know, go fix the problem, and they don't always understand or can see the unintended consequences downstream. So part of what we have really had to aggressively do is to help change our culture internally. We found that out ourselves through the process of trying to go through this, but we've been at this for 15 years now. And that's something that we are in the process of going out and have held several forums around Florida with owners to try and let them understand that it's not as simple as going in and saying, I want a piece of automation on my new air handler. You have to change your culture, and you have to be able to engage your staff. You'll have to retrain your staff in order to be able to keep these systems functioning.
Very good, yeah. So what we talked about, or what we decided here was, there are a few questions that as a consulting engineer I come across, and we thought it would be great to have a sort of a dialogue on what are some of these, what is the owner's point of view on solving these. So for example, I work across the country with a lot of healthcare facilities, and some of the challenges that we do see are some of what we are showing here. Lack of data. There is never a whole lot of data available, and in many instances, the number one issue we find in facilities, period, is sensor calibration. There are a lot of hot water boilers that are producing 40 degrees water. I don't know how that happens, but I have seen a fair share of those. So question to Mark, and working with Mark for the past 10, 12 years, UF has had a unique way of solving some of these. So Mark, talk about how, for example, you're solving the cooling coil issues. You know, we see a lot of degradation on cooling coils. How is UF Health overcoming that?
Yeah, and as time passes, those cooling coils can be impacted. They do become impacted. There's times when they can become so impacted that cleaning becomes just a moot point. You can waste, and we've wasted thousands of dollars trying to do that. So as we change our coils, what we're doing is we're installing differential pressure, which I know y'all are familiar with those, but differential pressure monitors to where when, based on an average, once we get to, say, 0.5 or 0.75 of an inch drop greater than baseline, we'll clean them. We don't wait till you get 2 or 3 inches. That's some of the things we're doing with our cooling coils. Obviously, with the staff training, we're starting to install more new technology. You gotta either find some of the people with the joysticks, and a lot of times then you can't. They're not out there. So trying to find these people that want to learn that want to be able to work that joystick with some extensive, complex training. It's things that we've had to get over and identify some of those people that can help us move forward. The override management, being able to override some of those points, setting up alarms, override reports, so we can help manage some of these overrides as we continue to age. Some of the good things that come with it, more and more tools. It's important that we train these people to be able to operate them efficiently.
And, overrides are one of the tools that, your maintenance engineer has to have sometimes. But what we've made them do is sign a name to it. And we run a report every day and say what's been overridden. And then you have to go back and fix it. You can't just ignore it.
One of the key points, at least I think that UF Health is doing is they are moving to data-driven preventative maintenance, or more towards the predictive maintenance. From the cooling coil point of view, since we have 9 years of data, we are able to look at patterns and see how fast or how slow are specific cooling coils getting degraded. And we can then predict when the cooling or when the replacement will need. So one of the values of having 9 years worth of data is to move towards that predictive maintenance state.
When we go to our forums that we've held, our peers often don't have a lot of data. And our message is data storage is cheap. It's a lot less expensive than an air handler. It's cheap. And it's, to be able to have that is just an invaluable tool.
One quick point, earlier Brad made a point about bad data, good data. So data is very valuable, but again, he made the point that since you have it doesn't mean you should map it to your system. The point I'll make in terms of when we talk about this holistic process is if you are investing in a sensor, think about it from a life cycle cost point of view. Meaning, if a particular sensor is going to need frequent calibration, why not invest in a higher-end sensor in the first place? Or if you're not willing to have a sensor calibration program, then why bother putting that sensor at all? So data is very important. We need to move towards a data-driven, predictive environment, but it's not easy. It comes with some first costs that I think are well worth it, but that holistic approach, you need to go back and have that in your construction standards. Especially working in Florida, the topic of humidity comes quite often. We've seen many of our clients are very afraid of humidity, especially when we are trying to do a discharge air temperature reset. And ultimately, we end up having a scheme with only allowing us only to go up to, say, 58 degrees of discharge air temperature reset. But that's not the case at UF Health. They're very, very aggressive in terms of how they are managing humidity, and would like Mark to address some of those best practices.
Humidity can be a big issue in Florida. I know if y'all do a lot of work here, you've seen that. And some of the people that we talk to in these forums, they say, we can't shut the building down. It starts sweating. Or so what are you doing? What kind of points do you have to monitor? And they kind of look at you, like they don't know what you're talking about. Again, the automation, the power of automation lets us really take these buildings. The more you optimize, the more delicate your building is. You're running that building on the edge. And I don't want to say that negatively, because the more you run it on the edge, the more high performing it is. So we're actually, to answer his question, when we talk about being able to do discharge air temperatures, we have, with the data that we have, we literally measure the energy inside and the energy outside, and we'll keep taking that up. The other day we were economizing at 72 degrees, just because the enthalpy was a point lower outside than it was inside. We took a picture of it. I actually wanted to get it on the slide and didn't get it up there. But discharge air resets when you're monitoring your return humidity. Obviously, you can't do it without data, and that's how we're managing it. Yeah, there's a lot of issues, like shutting buildings down at night, being able to use a temperature setting of 80 and a humidity, top humidity parameter at 60% before you bring the systems back on. It pays for itself in no time, but having that data allows us to do that, be able to run these high-performing buildings.
Using 68 degree or 72 degree fresh air, how many hours has that added in an average year that we're able to take,
We're able to go up sometimes as much as 3,000 hours, 3,200 hours a year.
more than where we were. That's a lot of money.
Yeah, and also back to the temperature resets, being able to not only go to 58 degrees. The other day we were in the office building that I showed you first, the 5-story building, we were up around 63 degrees and still maintaining humidity without, they've got a work order. If they were uncomfortable, they let us know right away without a single work order for that 2 or 3 days.
We also use the sensors on our new buildings to inform decisions about the existing buildings that might not be there yet, so that we can, if we're using fresh air here, we ought to be able to use it here as well.
Well, the other thing too, when you're doing economizer in Florida, some people say until it gets below 50 degrees, we're not going to turn we're not going to turn our economizer on. And I say 50 degrees. So what's the low end before you can start reheating? And they'll say 45. So you're going to run your economizer from 50 to 45? Well, how long does it take to get to 45 from 50? But if you can run from 72 to 45 or 74 even, to, it gives you, like Brad alluded to, it was, the time online gives you so much more, and it's a huge savings. It really is.
Very good.
Without the data, we couldn't do it.
Right.
Again, communication is a key strategy. Communication has multiple forms here, and we are going to split this question into 2 parts. One for Brad to answer in terms of he's very engaged with the community in Gainesville as such, and as well as the C-suite message of what this means too.
I think one of the important things that we've had to do in order to get our support for this program is working closely with our C-suite. So being able to have a conversation with our CFO and helping them understand that this is a long-term program, not an immediate transaction. Very often they think of things in our maintenance world as being, I have a project to replace this air handler or replace this motor, it's a one-time cost and we're done. So being able to go and present the fact that this is a management program, you're going to get a gain, but that gain multiplies over many, many years if you are able to maintain that instead of letting it creep back up to another condition. And the other part that's been helpful for us, even if that isn't sexy enough to get them to fully jump in, one of the pluses is when they can go out and stand in front of the press and talk about how sustainable your organization is and how we're committed to the community and to the millennial generation that is passionate about this and trying to get nurses and be in a place that we have to compete for employment. So they understand that as well. So there's a lot of different communication packages. I know they don't. Not every FM that you're going to work with out there gets the breadth of that conversation that it takes to carry this to the C-suite, and they're going to need your help in order to put together a package to go and help deliver a full program and not just a one-time project. I don't know, you want to talk about the facility staff, because that's another issue altogether.
Well, you saw the slide earlier where the discharge air temp kept getting manipulated down to 52, and we're fortunate. I know y'all probably work with a lot of health systems that maybe are siloed all over town. We're working with a guy now that has 9 hospitals down in Tampa, and actually Santa's part of this one, and trying to go to each of those each of those entities, because they're all a different group of staff, different trained. Some of them are the joystick, some of them are just the wrench type. We're fortunate at UF Health because we're all basically under one roof. And we manage from there. We manage our buildings from there. So it is mandatory. We have to communicate with these guys. When we first started, for the first year or so, it's like we do something and we don't tell them, and these emails get sent out. But save a lot of money, but it's nothing if everybody goes back and remanipulates what we did. So that's actually where some of those savings can creep up too. We've shown that over time, but communication with staff is imperative. You can't do that without talking to the people that are maintaining the equipment.
One of the very unique things that I've seen at UF Health is the way to fund some of this work. They have an internal performance contract type mechanism. And Brad, how did that get started?
We were fortunate. unfortunate and fortunate. When the new cancer hospital came online and we realized, I mean, it's a LEED Gold fully commissioned building. And it was running like an energy hog compared to our 1973 hospital. Part of it's code-driven air changes and everything else. I mean, that's what happens. And you can't avoid it. But we also got into the building and realized we could make some changes that Mark was working on, and that gave us a pretty big delta in savings. We were able to go to our CFO and say, you know, we'd like to take the savings, just like if we were performance contracting, and reinvest that in other components with the system. So we spent a number of years being able to take those savings and put them back into using our energy budget savings to go and make changes within the system. And that was no cost to the bottom line of the organization. And over time, they saw their energy budgets starting to drop, and which has really helped them and gave us a good, you know, a step forward in order to do some of these. Most of these things were incremental and were not, you know, major. We didn't have to go and ask for $13 million to do something. It's $100,000 here, it's $40,000 here, it's $150 over here as you go after some of these systems and tie them together.
Excellent. And I think this slide talks about the awards that the program has won. But Brad, you want to explain this energy graph?
It just shows the argument is not the first time savings, and it's really easy to walk in and say, look, I'm going to invest this. I've hired a commissioning agent, and we're going to save you know, $40,000 next year, $100,000. But that's not the story. The story is I can save that $100,000 year over year over year, and even as the cost of energy goes up, that gets bigger. So it's the additive value of this over time, you know. And in our world, at 3% margins, $28 million means to pay for that, I'd have to make $500 million worth of income in order to do that. So now all of a sudden the C-suite's going, oh, well, I hadn't really thought of it that way. And so that's helped us as a tool to be able to take that. I don't think most of our FM counterparts aren't necessarily going to grasp that, and you're going to have to help put that information together and make the business case. It's not one time. It's about keeping this thing going and being sustainable.
So basically, if you see that first number, $3 million, if we didn't do anything else but reduce consumption or reduce costs by 1% over the yellow, and then just let the last 5 years run out, that $3 million now becomes $28 million over 10 years, and to write that check, it takes $500 million, which is more than what our new hospital costs.
I guess our other message to them have been just do something.
Right.
Do it.
You know,
Get started.
Get started, because if you get started, you will see some savings.
So I think that is the key. As we talk through different conferences to different clients, there doesn't seem to be a sense of urgency about doing something. And I think one of the messages from UF Health has been doing nothing costs a lot. And that a lot of times as we bring other clients to UF Health, one big takeaway has been we have to do something, because doing nothing is not an option. And I think that is one of the key takeaways, for at least for me, from this approach. So Brad, I think this is our last slide. I think safe to say this room is full of commissioning agents. What would be your message as an owner to us?